So welcome to Develop with Ankon, and in today's video we will see how to write the binary search program in Python. So binary search is basically used to find a element within a sorted array. So this method actually takes around log n amount of time, so it is a very good method to learn. So let's start the algorithm. So what basically binary search do, it has been written in these 4 steps. So first it compares the element with the middle element, then if the key matches the middle element, then it will return return the middle index. So let me give an example, then it will be more clear. This example will be more clear. So let's have a sorted array, say 2 3 5 7 9. Okay, some more element, let me give 12 15 35. Okay, this much of element is there, and say we want to find the value of 15 from this array. Okay, from this whole array we want to find the value of 15 where this value exists. We want to find that index. Okay, our goal is that. So what will happen in the binary search of the middle element is found. Okay, right. Now if there is an array, so sorted array, and we find the middle element, say in this array the middle element will be 9. So how can we find the middle element? The middle element can be found by using this formula, the lowest index available, lowest index plus highest index divided by 2. So in this example there are total 8 8 number of elements, and the starting index is 0 and the ending index is 7. Okay, so by using this formula we can find out the middle element, that is the mid equals to lowest element, lowest index. Now the lowest index is what? That's 0, right? So 0 plus the highest index here is now 7, plus 7 divided by 2. So this will give, so this will be an integer division. Okay, so this will be an integer division, so I will get a value of 3 here. Now let's find where does the value 3 occurs. So 3 basically 0 1 2 3. So this one is the middle element right now. Now after finding the middle element, we will compare both the compare the key with the middle element. Okay, and see which one is greater. If the key is greater, okay, if the key is greater than the middle element, then we can clearly see that this array is required right now, and we do not need this array, because we know that the value 15 will not be in this region, right? It always be greater than the key, so it will must lie in this region. So what we are doing, we are just dividing the array in one step only, right? Say we are discarding this array after finding the middle element and comparing with it with the key. We are discarding this much of element, this much elements, and now our array becomes this. Now let's find the index. Sorry, the indexing will be wrong here. Now we will initiate our lowest index as the index of the 9th element, that is mid plus 1, that is the 4th index. So from 4 to 7 is our array right now. 4 to 7 is our array right now, and finding the middle element will be 4 plus 7 divided by 2, that is 11 by 2, that is 5. 5 should be the middle element right now. So where does the 5 occurs? So 5 is basically this index, right? 12. Now we will check whether this 12 is greater than or less than the key 15. So we can see clearly that 15 is greater than this 12 number. So what we will do, we will discard again this much of the array, and we will take this much of the information, because we know that the element is to be found will be in this region, as as from the middle element to the left hand side, all the elements are lesser than the middle elements, and the key is greater than the middle element, so it should lie in the right hand side. So in this way we are again updating our array, that is the mid plus 1, that is 6. From the sixth element to the seventh element is our array now, and our mid will become 6 plus 7 by 2, that is 6. Okay, now the middle element is at 6, this one. So okay, one more thing, that we are doing integer division here, right? So 6 plus 7 comes 13, but as we are doing an integer division in Python, so it is becoming 6, right? 13 divided by 2, integer division by 2 gives us a 6. Okay, now we will check for the 6th index. Now we can see the 6th index has matched with our key, and we got our result. So how many steps did it take? So it took around 3 steps to complete, right? And the binary search gives a total time complexity of big O of log n. And why does it give this kind of time complexity? As you can see, it is dividing in each step, it is dividing the array into two parts. One part has been discarded and one part has been taken into account where the next iteration is going on. Okay, so this was about the binary search, and now let's implement it. So let me define a function binary search that will take an array and a key as its parameters. I will define a low for the lowest index. Initially the lowest index is 0, as we have shown in this example, and the highest index will be length of the array minus 1. Okay, means the last index of the array minus 1, and we are taking a mid element, let it be 0 right now. Now we will apply a while loop, and we will check the low is less than or equal to high. Now why are we doing this step? Because when the low or the high crosses each other, then there is no sense to iterate over it. Means firstly we are taking low as 2, and means the first index, and the high as the last index, right? But when they will cross each other, say at this point the high becomes 3 and the low becomes 15 right here, so there is no meaning to do the operation, right, or the binary search operation. So that is why we are discarding that, and we are running our while loop, low is less than or equal to high. Now here we will find out the mid element first, that is the high plus low integer division by 2, right? Now if the key is greater, we should ignore the left half, right, as we have discussed in that example. So let's write the if statement here. If the array is of the mid is less than the key element, then low will be equal to mid plus 1. Else if the array of the mid element is greater than the key, then what should happen? Then the high should be equals to mid minus 1. Okay, we will discard the left hand side, means the right hand side. So say if our key was 3 here, okay, and firstly our mid will be at 9. So is it better to go to the left hand side or the right hand side? So left hand side will be our right option, right, to go or visit the left hand side's options. So that is why we are doing this step. High is equal to mid minus 1. So it will take actually this much of array, it will discard all this array, okay, if our key is 3. After that step, if both the steps failed, then it means that we found out our element, and we should return its index. So index it will be mid. Okay, if both these two steps fail, means becomes false, then we are at the middle element. Means what is the meaning of this statement, that if these two statements become strong, means if the array of the mid element is less than a key becomes false, and the array of the mid element is greater than the key becomes false, then what does it mean? Then it means that array of the mid element is equals to the key. Okay, it equals to the key, so we should means we found out our element and we should return that middle element from here. Okay, after that, if the while loop is over but still we did not get any result, then we can say that there is no key that is present over this array. Means, say the case of 32, so we can clearly see the 32 element is not present in this array, so for that reason we will return -1. For this kind of cases we will return -1. Okay, so now let's test it. Name equal to main. Let me define an array. Two comma 3 comma 5. Let me take this array only. Okay, now let's apply our binary search, and so binary search will return our index, right? So we will make an index variable and call the binary search and pass the array with the key. So what kind of keys we want? Say we want the index of the element 12. Okay, for the first example, and after that, if the index is not equal to -1, then we will print 12 is present at, so 12 is present at index format and index, or else the element 12 is not present. So let's run this right now. Oh, sorry. So you can see the result is 12 is present at index 5. Now let's say let's give an element that is 31, and let's see whether it is present over the array or not. Sorry, we didn't save this one. Now let's run it. So you can clearly see the element 31 is not present over here, and in the array also we are not getting any 31 element. So this was about the binary search. I hope you like the video. If you like the video and want the more this kind of video, then please like, share and subscribe to this channel. If you have any kind of doubt, then ask me in the comment section. Thank you.